Today we will practice solving compound inequalities containing two-step inequalities. So let's get started. With compound inequalities, we have two or more inequalities, and they're going to be connected with one of two keywords, either the keyword and or the keyword or. So in this example, we have the keyword or. To solve these, we're going to solve each inequality separately and then combine the answer using that keyword. So looking at the first inequality, to isolate that y, first we're going to add 2 to both sides. This gives us 2y less than negative 6. And then divide both sides by 2. And we have y less than negative 3. We'll bring down this or, and then solving the second inequality, again, first we'll add 2 to both sides. Now we have negative 2y less than negative 4. And then we divide by negative 2. Just like when we solved other inequalities, if we multiply or divide by a negative, we're going to change the direction of the inequality. So we end up with y greater than 2. Graphing this, we have y less than negative 3. So we'll have an open circle at negative 3. And we'll shade everything to the left of negative 3, all the numbers smaller. And then we have y greater than 2, so we'll have an open circle at 2. And then all numbers bigger than or greater than 2 will get shaded. Since this is an or statement, it just has to be in one of these two, in either of these two. So we'll go ahead and shade all the numbers greater than 2. And all the numbers smaller than negative 3. In interval notation, so this includes all numbers smaller than negative 3, so it extends to negative infinity, open parentheses, negative infinity, comma, and then that boundary is at negative 3, and we'll use a closing parentheses because negative 3 is not included. The symbol for union, which is this U, again, a union uses the or keyword. Then we have an open parentheses for the boundary at 2, comma, and this extends to positive infinity. So we'll use the infinity symbol and then the closing parentheses. For this next problem, these two inequalities are joined with the keyword and. We will solve this by solving each of these inequalities separately. So let's subtract 7 from both sides for this first inequality. We have 3z less than 12. And then we divide by 3 to get that z all by itself. So we have z less than 4. We will bring down the word and to connect these two inequalities. Now solving the second inequality, we'll add 5 to both sides. We have 2z greater than 4, and then dividing both sides by 2, we end up with z greater than 2. So for z less than 4, we'll have an open circle at 4, and we're going to shade everything to the left or smaller than 4 for that first inequality. Second inequality is z greater than 2, so we'll have an open circle at 2, and then shade everything bigger than 2. This is an and statement, so this is the intersection. It's what they have in common. So the solution has to be both smaller than 4 and bigger than 2. So this is where these overlap. So we have this small section right here, and it does not include the number 2 nor the number 4. In interval notation, since 2 is not included, that boundary of 2 is not included, we're going to use an open parentheses, and then the number 2, comma, and then on the right we have the number 4, and it is also not included, so we'll use a closing parentheses. Neither 2 nor 4 are included. These are not solutions to this compound inequality. Parentheses are used to indicate that the boundaries are not included. Finally, we have the compound inequality -19 less than -2x minus 7 less than or equal to 1. This is a compound inequality, and when it's written like this, the key word is and. These two inequalities are joined by the word and. And you can split this up into two inequalities and solve each of them separately. So what are those two inequalities? So we're going to start in the middle with what's in between the two inequality symbols, and then we're going to go to the left. And so this is the first inequality. So -19 less than -2x minus 7. And then for the second inequality, again, we start in the middle with -2x minus 7, and then we move to the right. And so our second inequality is -2x minus 7 less than or equal to 1. And these are joined with an and keyword. And you can solve these two inequalities separately and get the answer. But instead, let's solve this compound inequality altogether. Again, the goal is to get x all by itself. We have 7 subtracted from it, so we need to add 7. So that will result in -2x in the middle. But what you do to one side, you got to do to the other sides as well. So we're going to add 7 to the left and add 7 to the right. That leaves us with -12 less than -2x. And then this is less than or equal to 8. Our x is now multiplied to -2, so we'll need to divide by -2. That results in an x in the middle. We got our x by itself, but we also need to divide both the left side and the right side by -2. So -12 divided by -2, that's 6. 8 divided by -2 is -4. And if you multiply or divide by a negative, you have to switch the direction of that inequality symbol. So we end up with 6 greater than x, greater than or equal to -4. And this is a valid solution, but it's best to put the smaller number, in this case -4, on the left. So we'll rewrite this as -4 less than or equal to x less than 6. And then writing this in interval notation, we have -4 as our left boundary. So we'll use a bracket to show that -4 is included, comma, 6. And then 6 is not included, so we'll use a parenthesis. Graphing this, we have a closed circle at -4, an open circle at 6, and we will shade everything in between this. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these two problems. This first compound inequality is joined by an r. We'll go ahead and solve each of them separately. So for the first inequality, we end up with a less than 1. In the second inequality, we end up with a greater than or equal to -2. When we graph these, so we have a less than 1. So that's going to be an open circle at 1, and it's a less than 1. So we're going to shade everything to the left of positive 1. Then for a greater than or equal to negative 2, we have a closed circle at negative 2, and then everything bigger than negative 2. And this is joined by an or, so it just needs to be in one of those two sets of numbers. All numbers are either greater than or equal to negative 2 or less than 1. So this ends up being the entire number line. So we're going to have all real numbers. So all numbers that are on that number line. And this is written in interval notation as from negative infinity to positive infinity. In this second problem, we have the compound inequality 1 less than or equal to 5 plus 2b less than 9. Again, when written in this format, the two inequalities are joined with the word and you can solve these separately. The first inequality would be 1 less than or equal to 5 plus 2b. And the second inequality is 5 plus 2b less than 9. But they do not have to be solved separately. Yet we can subtract 5 from the middle and both sides, ending up with negative 4 less than or equal to 2b less than 4. And then we'll divide by 2, resulting in negative 2 less than or equal to b less than 2. And in interval notation, we have a bracket for the left boundary with negative 2 included, and a parenthesis for the right boundary with 2 not included. Continue practicing solving compound inequalities, and I'll see you in the next video.